Hello students, welcome to Eshwari channel. Students, in this video we are going to find how to find the order of basic nature of alkyl amines. So first let us learn what is alkyl amine and how to find which is more basic. Let us learn first the formula for ammonia. You know the formula for ammonia is NH3 and there will be lone pair of electron on nitrogen. So out of this 3 hydrogen, if I replace one hydrogen with R group, R, N, hydrogen and hydrogen. Out of 3 hydrogen, 2 I have written and 1 hydrogen is replaced with R group and there is one lone pair of electron. So now this is called as primary amine. Same way, one more hydrogen if I replace with R group, R, N, H, R, lone pair of electron. This is called as secondary amine. And if I replace even this hydrogen with R group, R, nitrogen, R and R, there is a lone pair of electron. This is called as tertiary amine. And if R group is alkyl group, if R is alkyl group, alkyl means it can be CH3 group, methyl group, C2H5 ethyl group, then it is called as alkyl amines. So now the question is, which is more basic in nature? Whether primary amine is more basic or secondary amine is more basic or tertiary amine is more basic in nature. So let us learn the trick to find that. So first of all, what is the base? So base means if a species gives out a lone pair of electron, so it should have a lone pair of electron, and if it easily gives out lone pair of electron, it is called as base. So here you can see there is a species, example B. So on this, if there is lone pair of electron, so if it donates this lone pair of electron, then this is called as the base. So in amine you can see there is lone pair of electron on nitrogen. If nitrogen donates this lone pair of electron, then it is called as base. So even here you can see in secondary amine there is lone pair of electron. So base meaning is it can give away its lone pair of electron is called as base. So now let us find the order of basicity of alkyl amines. So first let us learn in gaseous state. So in gaseous state, the order of basic character is second in tertiary amine, which will be more basic than secondary amine, which is more basic than primary amine. So this is the order of basicity in alkyl amines in gaseous state. So what is the reason for that? So let us see the reason. So write tertiary amine. Tertiary amine is R, N, R, R, a lone pair of electron. Secondary amine is then primary amine. There is lone pair of electron. So this is tertiary amine, this is secondary amine, this is primary amine. So R group is alkyl group. Alkyl group means methyl group, ethyl group. So you know that it shows plus I effect. So plus I effect meaning is R group releases electron or pushes the electron towards nitrogen. So 3 R groups are there. It pushes the electron towards nitrogen. So nitrogen becomes rich in electron. So here 2 R groups are there which shows plus I effect. And here there is 1 R group which shows plus I effect. So where electron density is more on nitrogen, here electron density is more on nitrogen. Why? Because there are 3 R groups showing plus I effect because of which electron density increases. So nitrogen can donate this lone pair of electron easily. Therefore, it is more basic in nature. And here only two R groups. Therefore, it comes after tertiary. And here there is only one R group, so it comes last. So this is in the gaseous state. So let us consider in aqueous state. So aqueous state means in water. So in water the order is slightly different. So in aqueous state you can see it depends on three factors. One is plus I effect, second is solvation, and third is steric hindrance. So inductive effect already we have seen. Inductive effect order what we have seen is tertiary amine is more basic than secondary amine, more basic than primary amine. So we have to see in solvation and then we will see in steric hindrance. So first we will take solvation. So whenever you take amine in water, this is amine. In aqueous state means in water, so there will be H plus ion. So this lone pair of electron will attract this H plus ion and it will form R, N, hydrogen, hydrogen. So already it has two hydrogens and this hydrogen will be attached to nitrogen and nitrogen will get a positive sign because it is losing this electron to hydrogen. Therefore, nitrogen will get a positive sign. So now this becomes cation. So there is a positive sign. So this is a cation. So students, in a cation, if stability increases, then basic strength also will increase. So let us see. Let us take all the three amines. Tertiary amine we will take R, N, R and R. So nitrogen, after donating this lone pair of electron to hydrogen, it forms a bond with hydrogen and it will be getting a positive sign. So this is tertiary amine. We'll write secondary. Nitrogen, R, hydrogen and then one more hydrogen, that is it attracts this hydrogen and it gets a positive sign. So this is secondary. Primary, R, N, H, H and then one more hydrogen. So hydrogen and then positive sign on nitrogen. So this is primary. So students, here when you add into water, what happens is H2O, this oxygen and hydrogen, they form hydrogen bonding. So there will be hydrogen bonding between oxygen and hydrogen. So here there is only one hydrogen which forms hydrogen bonding. So here you can see there are two hydrogen atoms in secondary amine. So H2O. So here with oxygen and hydrogen there is one hydrogen bonding and here H2O there is one more hydrogen bonding and here there are three hydrogen atoms. So with water one hydrogen bonding here and here one more hydrogen bonding and here there is one more hydrogen bonding. So this is called as solvation. So solvation means whenever you dissolve this, add this amine into water, it forms hydrogen bonding, due to which what happens is energy will be released. Whenever a bond is formed, their energy will be released and the molecule will get lesser energy. So here you can see there are three hydrogen bonding. So three bonds are formed. Three bonds are formed means more energy is released. So this molecule will be having less energy. So less energy. Whereas here there are only two hydrogen bonding. So compared to this will be having more energy. and here there is only one bond is formed, means less energy is released. So here you can see the energy released here will be less when compared to this. So after releasing energy, this molecule will be having very less energy. Energy will be very less because it has released energy. So lesser the energy, stability will be more. So already what we have written here, if stability is more, then basic strength will be more. So in primary amine, you can see the energy is less. If the energy is less, stability of that molecule will be more. If stability is more, then basic strength will be more. So primary amine, basic strength is more. So here you can write in solvation, primary amine will be more basic compared to secondary compared to tertiary. So this is about solvation. So remember that whenever energy, the molecule loses energy, so it will be having less energy. So less energy means it is more stable. So here this molecule is having only less energy, so it is more stable. More stable means basic strength will be more. So next we will go for steric hindrance. Steric hindrance. So steric hindrance meaning is overcrowding. So take tertiary amine, nitrogen, R group and R group. There is lone pair of electron. This is tertiary amine. Take secondary amine, R, nitrogen, R, hydrogen. This is secondary amine. Primary amine is R, N, H and H. So this is primary amine. So lone pair of electron will be present. So students, here R group meaning it is bigger group. So it is a bulky group. So I'll write it as bigger group like this. So this is very bulky in nature. And here two bulky groups are present. And here only one bulky group is present. So now proton should approach this lone pair of electron. If it is more basic in nature, meaning is it should donate this lone pair of electron to proton easily. But whereas here, because of bulky group, the proton cannot reach this electron. It is difficult for it to reach this electron. Whereas here there are only two bulky groups. So proton can approach this lone pair of electron easily compared to this. Whereas here there is only one bulky group. So proton can approach this lone pair of electron easily. So steric hindrance meaning is crowdedness. So crowdy. So around nitrogen. So if it is highly crowded, it is impossible for this proton to approach this lone pair of electron. So here hydrogen can approach this lone pair of electron easily. Nitrogen can donate this lone pair of electron easily. Therefore, this is more basic. Primary is more basic. So let us write the order. Steric hindrance. Primary amine is more basic than secondary amine, more basic than tertiary amine. So now in aqueous state, all these three factors will be acting on amine. So because of which experimentally you can see the order. If the R group is C2H5, experimentally it is found that secondary amine is more basic than tertiary amine, more basic than primary amine if R group is C2H5. If R group is CH3, then the order will change. It will be secondary amine more basic than primary, more basic than tertiary. So this is what we have to remember. So three factors are happening. We should not consider one factor. All these three factors are acting on this amines. So experimentally, this is the order we see. If R group is ethyl and if R group is methyl, this is the order we see. So what is the trick to remember? So students, see here in this two, common is secondary. So here also secondary, here also secondary, we can remember. So next is ethyl group and this is methyl. Ethyl group is bigger than methyl group. So bigger number will come next. So tertiary and then primary. Whereas here methyl group is small. So small number will come first, primary and then tertiary. So we can remember like this. So secondary greater than tertiary greater than primary. Here secondary is more basic than primary, more basic than tertiary. So this is how we remember. So I'll meet you in the next video, students.